So, seeing as how far we've already come with the technology, how do you see the future of automation and networking of machines and work processes in agriculture evolving, especially with respect to the advancements in hydraulic control systems and their integration with the
Yeah,
electronic intelligence?
yeah, different levels, of course. We have the highest level where we have machine interface communication, one machine with the other machine. Um, this is in agriculture state of the art already. GPS control, driving, and so on. One machine is the master, the other machine without driver is following. So this is there, it's done. On the machine, I would say there are the next big steps now because the performance precision on the machine will be higher. The driver will not control all movements by themselves. I don't know if you looked in the cabin of a tractor, how many knobs and turns and so there are and buttons. So I'm not able to drive such a tractor. Um, and I think this will be a big change. So the tractor become more simple. It will be more a tool to to pull the attachment, and the process is done on the attachment, and the attachment gets more electronics on it, more sensors on it, more smart valves, and become more complicated. And to solve this, you need good and simple and reliable products. And then we talk again about these advantages with onboard electronic valves, pumps.
Right.
And I would say the typical hydraulic mechanical products, which are very reliable, but with a lot of very special problems here and there, this will be replaced by smart electro hydraulic components. So the hydraulic will be there as a muzzle, but there will be a brain on top of it near to the hydraulic. And this will be the future. And then we see also, of course, the topic of electromechanics. But I would say this is for smaller, simple actuation with low forces. There also hydraulic will perhaps a little bit disappear. But hydraulics has a still and everlasting benefit of extremely high forces with very low space and weight consumption. So the efficiency of the hydraulic is very high in this area and is robust and simple, so it will stay. But the components become more smart. And then, of course, also topic we didn't discuss, but they must become also more efficient because we will see more electric drives, battery-driven vehicles. So efficiency is a topic, but hydraulic is not inefficient. That's absolutely not the truth. So hydraulic could be absolutely efficient when you set up the right system.
When
This
we
is
have these mechanical components that are made to last a very, very long time, and then we have an electronic system controlling it, are we able to then, like, this is a modular block, if it fails or if it wears out the electronic part, do you just take it out and then put a new one in and it's just that simple to do? Or
yeah, at the end, yes, it is not, I would say, not in all components already the same way, but that is at least the logic. You have to have a very simple possibility for override, and this is state of the art. So you can also manually override it if electronic completely fail. It is not always important. Some machines say, I don't need it. Some machines say, okay, I want to have it, but this is state of the art. And the other topic is really a very simple exchange of onboard electronics. And this is, I would say, it's not 100% solved, but you see more and more it goes in that direction, plug and run of electronic components. Also self-learning components. So if you take out the defect one and put the new one in it, the section beside learn the information to the other one. And the driver or the end user or the service guy has to do nothing. So this is, I would say, it is not 100% done in the market, but I would say the development direction is going in that direction. So it must be simple, robust, and if it is defect, it must be simple to replace it.
Well, that's great. Was there anything else that you wanted to add that we may have missed discussing today before we say goodbye?
No, I think we talked about all these points. Important, as I said before, is that we don't mix these communication between Tractor and implement. This is this ESO bus system, which is absolutely state of the art, and nobody will change it. But on the implement, especially, we see a lot of benefits with CAN bus technology, with smart components and exchange of information and data, and using them to optimize the process and also to become more resource friendly. Is this the right word? Because the process become more precise, and so we have less losses in the complete chain from energy, but also from when we talk about seed or other things. And this is a very important change we see here.
Right.
And we hope that we can support this with our products.
Terrific. Well, I think we've cultivated a lot of great information today, and I want to thank you so much for joining us, Marcus. And I want to thank the viewers for joining us as well. So until next time, this is Sharon Spielman with Power and Motion. Stay curious.